Alright, today we're going to start talking about scientific notation. And what we're going to do is we're going to review some of the things associated with the scientific notation. So we're going to talk about expressing numbers, but not only expressing numbers, but we're going to do some mathematical operations in scientific notation. Scientific notation is a method that's used to represent very large or very small quantities. Generally, it's going to be written as m times 10 to the nth, where m is going to be a value that is greater than or equal to 1, but it has to be less than 10. So it can be 1, it can be 2.4, it can be 8, it can be 9.99, but it cannot be equal to 10. N is just going to be any positive or negative integer. And again, if you remember what an integer is, it's basically a whole number. So we could have a positive 15. A positive 2, positive 1. You could have a negative 3, negative 78, things like that. So n is just going to be any positive or negative integer. Now, when you look at these, 74 is bigger than 1, but 74 is not less than 10. So this first one is incorrect. When you come down to the last one, 0.74, well, 0.74 is not bigger than 1. So that's the reason why it's out. When you look at 7.4, this one is correct. The m value is between 1 and 10, and then again there you notice the 10 to the 5th. All of these numbers actually are exactly the same, but in proper scientific notation, it's this one right here that is your correct expression in scientific notation. Write the width of the universe in scientific notation. So here's the number. Got a very large number here. It says, where is the decimal point right now? Well, it's not actually shown, but that decimal point's actually going to be right in there. So it says it's right after that last zero, like I was showing. Okay? It says, where would you put the decimal to make this number between 1 and 10? So we're going to start moving it to the left here. And again, we're going to move it all the way over here until we get a number that's between 1 and 10. So it says we're going to move it between the 2 and the 1. So again, we're going to take that decimal, we're going to move it all the way over here until it's 2.10, and then we're going to express it. It says, well, how many spaces did we move it? So if you go ahead and count up all of these zeros and how many spots we moved it to get between the 2 and the 1, you're going to find out that we moved it 23 spaces. Now it says when the original number is more than 1, that exponent is going to be a positive value. So the answer in scientific notation is going to be 2.1 times 10 to the 23rd. Now again, that was going to be representing an extremely large number. Now on this one, we can go ahead and express this one in scientific notation. Now we've got a number that's extremely small. Now yesterday we talked about using prefixes. Today we're talking about using scientific notation. It says where would the decimal go to make a number or make a correct value that's between 1 and 10. So again, we're going to move it over here until we get a number that's greater than 1 but less than 10. So we're going to move it between that 9 and that 0. Okay, so we're going to move it all the way over to 9.02. So as the decimal was moved how many places? So if you count how many you moved it over, we moved it 8 spots. When the original number is less than 1, okay, so this number up here you can see is less than 1, then our exponent's going to be negative. So this is actually going to be a negative 8. So your correct answer is 9.02 times 10 to the negative 8th. Let's look at some of the mathematics associated with scientific notation. If we look at addition and subtraction, it says when adding and subtracting in scientific notation, number 1, make sure you have common exponents. Okay, so you have to make sure that they're all in 10 to the 4th, or they're all in 10 to the negative 7th, things like that. So again, number 1, make sure you have common exponents. Number 2, you're going to add or subtract those m values. Number 3, make sure your final answer is in proper scientific notation. So when you add or subtract those m values, make sure that m value is greater than 1 but still less than 10. And if it's not, then otherwise you'll have to make sure that it is in proper scientific notation, okay, to get it between 1 and 10. Okay, so for example, so let's take 7.4 times 10 to the 6th plus 3.7 times 10 to the 7th. Now when you look at rule number 1, it says make sure that you're in common exponents. And when you look here, I have a 10 to the 6th and a 10 to the 7th. Okay, so I'm going to make sure that I have common exponents. What I did is I made sure that I moved both of them or had both of them as 10 to the 6th. So all I did was just move this one over 1, so now I have 37 times 10 to the 6th. Okay, number 2, it says, since this is addition, we're going to add our m values. We're going to add the 7.4 because there's that m. We're going to add it to this m, 37. So 7.4 plus 37 is 44.4. And then it says drop down the common exponent. So when I drop down the common exponent of 10 to the 6th, I've got 44.4 times 10 to the 6th. But when you look at Rule 3, it says make sure your final answer is proper scientific notation. 44.4, that is bigger than 1, but it is not less than 10. So I got to move it over here once to the left to get a correct scientific notation number of 4.44 times 10 to the 7th. Let's look at multiplication and division. When multiplying, rule number 1, we're going to multiply the m values. Number 2, you're going to add your exponents. And rule number 3, you're going to finally make sure that it is in proper scientific notation. Division. Okay, first thing you're going to do, you're going to divide your m values. Now, since division is the opposite of multiplication, if you notice up here when we multiplied, we added the exponents. Down here, what we're going to do is we're going to actually subtract the exponents when we divide. And then finally, rule number 3, again, make sure it is in proper scientific notation. Let's look at a couple of example problems. Okay, first one, we're going to look at 7.6 times 10 to the 4th, and we're going to multiply it by 4.37 times 10 to the 11th. Okay, we're going to multiply the m values, 7.6 multiplied by 4.37, and we're going to get a 33.212. We're going to add our exponents. We're going to take 4 and add it to 11. 4 plus 11 is 15. Putting it all together, we get 33.212 times 10 to the 15th. But that's not proper scientific notation. Backing it up 1 to get it between 1 and 10, we're going to get 3.3212 times 10 to the 16th. Let's look at a division problem. 1.6 times 10 to the 3rd divided by 9.7 times 10 to the 7th. So first thing we're going to do is we're going to divide our m values. We're going to take 1.6 divided by 9.7. We're going to get 0.165. Next thing we're going to do is we're going to subtract our exponents. We're going to take 3 minus 7. 3 minus 7 gives me a negative 4. Putting it together, I get 0.165 times 10 to the negative 4th. Thing is, we're not in proper scientific notation, so I got to back that up 1 to put it between 1 and 10 to give me a final answer of 1.65 times 10 to the negative 5th.